Okay, today we're looking at separating variables. That's the name of what the process is. So in integration, sometimes we end up with things that have x's and y's in them, and we still want to integrate. And we know at the moment that we integrate a y thing to get an x thing, but sometimes they're all on the same side. So if we've got something like this, dy by dx equals 1 over y. All right? So this says we've differentiated with respect to x, but we've got a y in it. So if we're integrating to go backwards, we need to split them up into x's and y's. To get this over here, we're going to multiply. dy equals 1 dx. But the y we want on this side, so again we multiply. So we end up with two different problems. Then we're going to integrate each one. All right? This one's going to be integrated in terms of y, so we get y to the power of 2 over 2. This one is going to be integrated in terms of x, so 1 turns into x. But we've still got that problem integration of our plus c, all right? Now, we don't need a plus c on either side because c is just sweeping up any sort of constant it could have been. So if this side had plus c and this side had a plus d, we could take it over here and make it c minus d, which is still a constant. So we just have it on one side and it sort of collects everything that's out there. Quite often we want to write this in terms of just y. So it might be that we actually have to go to the point of multiplying and okay, that c is still part of it, but we've ended up with now y equals. Sometimes we don't need to do that. We don't actually have to tidy it up to be a y equals. So if we have something like this, all right, what we want to do here is, again, we want to separate the x's and y's. So we're going to bring the y over here. So that y is going to come to this side. We're going to leave everything else over the other side. So it's going to be divisible because it's multiplied over here. And we're going to end up with 3x cubed, and we're going to multiply the dx over here. So again, two different ones. This one in terms of y, this one in terms of x. So when we integrate y, what do we get? You remember? No, we don't make it into a negative 1. 1 over y integrates to the ln of y. All right? And this side, add 1 to the power, decrease by the new power, and add c. So that's what we're going to get. When we rewrite this, we have to get rid of the ln. So that means taking e to this to get to there. So to undo an ln, we use an e. This side will come to being y. This side is e to the power of 3x to the 4 over 4 plus c. Now that part there has to stay like that, but this bit here sometimes can be written as a, e to the power of 3x to the 4 over 4. So because this is actually multiplying by a constant, we can actually pull it into one variable called a in the front. All right? So that's another technique. So looking at one more, I've got x cubed dy by dx plus 5xy equals 0. All right? I want to write the general solution to this problem. So I need to make sure that I'm splitting it up, x's and y's. So I'm going to take that over that side. Right, I'm going to put the x cubed underneath. Now I'm going to cancel. I'm now going to put the y over this side, so dy stays, and I want the y underneath because it's on the top, and then the dx is going over this side, and I've got negative 5x to the negative 2 dx. At that point, now that I've separated the variables out to x's and y's, I can now integrate. So this one again gets to be ln of y, and this one gets to be add 1 to the power is negative 1 times by negative 1 is 5x to the negative 1 plus c. All right, and then you can go through the same process of unpacking what happens to c. Okay, good luck.